Okay, so let me just show you how to get the slope here. Okay, the only tricky one is the best fit line. Okay, the best fit line, you're going to just draw a line as best you can see through those points, and it might not even touch a single point. And then we're just going to go rise over run for the best fit line. Now your numbers are going to be different from mine because I put my line on there all by myself, and I'll be highly suspicious if you turn in a set of numbers that are exactly the same as mine. But if you look at this line, it actually starts at 0 and goes all the way up to 10. Okay, so my rise is easy. It's 10 minus 0. Okay, and now we got to do a little reading here, right? This number here, gee, that's really tiny. Let's see. I'm going to say that that's just 0 for the starting point there. Okay, and then this spot here, well, where does that go? Kind of goes in the middle right there. Okay, so that's 0.31, 0.32, 0.325, right? Yeah, 0.325. So it's going to be 0.325 minus, well, really that's like, that thing there is like 0.001. It's not quite 0, right? Okay. So then I'm just going to put that in my calculator. Okay, let's see. Parenthesis 10 minus 0 divided by 0.325 minus 0.001. And I get 30.86. Right, and then the units of this, it's always good to have the units. Rise is in newtons, run is in meters, right? That's newtons per meter. And that is, by the way, the K of the spring, right? We should recognize that. Okay. Now, if you look at the steepest line here, IB wants you to go exactly from the top of that error bar to exactly the bottom of that, unless one of those points, the last or the first, is like some outlier. Like this line, this point was way up here or something like that. Okay. So we don't have to like read the graph. We can just look at the data table. Right? The steepest line is going from this point here, the lowest spot here, to the highest spot right there. Okay? So it's going to go from 1.1, which is this number here, minus the uncertainty. So the uncertainty is 0.5, right? And then it's going to go to the highest it could be, which is, well, it's 9.4 plus 0.5, right? Okay, so the steepest line, if we want to do that slope, okay, that's going to be, well, the rise is 9.9 minus 1.1. Right? And then the run, if you look at the run's easy. The run is 0.3 minus 0.05. Right? So we can do the steepest one. That's easy. 9.9 minus 1.1 divided by 0.3 minus 0.05. The steepest it could be is 35.2. And again, that's newtons per meter. So that's the max K, right? And then the minimum, we're going to do exactly the same thing, only we're going to go from the highest point here to the lowest point there, right? So the highest point is 0.5 more than 1.6, so it's 2.1. And then this point could have been as low as 8.9. That's 9.4 minus 0.5. Right, so my min slope, right, is equal to, and I'm just going to go 8.9 minus 2.1. And then the run is exactly the same run we had here, right? So it's 0.3 minus 0.05. And I could do that on my calculator. just change that to 8.9, 2.1, right? And I'm all set. 27.2. Now comes a tricky little bit here, okay? I've got a max slope and I've got a min slope. Here's my best guess, right? Okay, so I'm going to go max minus min over 2 to get my uncertainty, right? So I'm going to go 35.2 minus 27.2 divided by 2. And I get that the uncertainty is exactly 4, right? Right, so I did 35.2 minus 27.2, right, divided by 2. That's how you do the uncertainty, right? And that is 4 newtons per meter. So now we got to figure out what's clever to say, right? It would be stupid to say 30.86 plus or minus 4, because here we're specifying in the hundredths of a place, right? So what I'm going to do is I'm going to say that's 31 plus or minus 4 newtons per meter. Okay? And that's because uncertainties in IB land should be 1 sig fig, and then these digits should line up. So that's in the ones place, and that's in the ones place.